Quantum physics, also known as quantum mechanics, is a fundamental branch of physics that deals with the behavior of matter and energy at the smallest scales, typically at the level of atoms and subatomic particles. It was developed in the early 20th century to address phenomena that classical physics couldn't explain, particularly in the realm of atomic and subatomic particles. Key principles and concepts of quantum physics include wave-particle duality. Particles, such as electrons and photons, exhibit both wave-like and particle-like properties. This duality is encapsulated in the famous double-slit experiment, where particles display interference patterns like waves. Quantization. Certain properties, such as energy levels, are quantized, meaning they can only take on discrete values. This is in contrast to classical physics, where quantities are continuous. Uncertainty principle, formulated by Werner Heisenberg, this principle states that it is impossible to simultaneously and precisely know certain pairs of properties, such as a particle's position and momentum. Superposition. Particles can exist in multiple states or locations simultaneously until they are measured or observed, at which point they collapse into one of the possible states. Entanglement. Particles can become entangled, meaning the state of one particle is directly related to the state of another, even if they are far apart. Changes to one particle instantaneously affect the other, regardless of the distance between them. Quantum tunneling. Particles can pass through energy barriers that would be insurmountable according to classical physics. Quantum physics has been highly successful in explaining the behavior of matter and energy on the quantum scale. It forms the basis for much of modern technology, including semiconductors, lasers, and various medical imaging devices. However, it also challenges our intuitive understanding of the physical world, as many of its principles seem counterintuitive based on classical physics. The interpretation and philosophical implications of quantum mechanics continue to be topics of debate among physicists.